Hello, everybody. This guy is not actually a part of this question, but I really wanted you guys to see an example of one of these and see exactly what happens. What are we going to see with HO here? The first thing I want to make very clear is that this is not HO minus. This is not a hydroxide ion. Okay, there's no negative charge here. This is a neutral species with hydrogen and oxygen, so it's not that guy. That is a different thing with a very different chemistry than what we're looking at here. Alright, but we're going to begin as we always do. We're going to write down what types of atoms we have. We're going to write down their electron configuration. We're going to see that this guy has 6 valence electrons. This guy has 1 valence electron. We have 1 hydrogen giving us 1 electron plus 1 oxygen giving us 6 electrons. And that's going to be 7 electrons. Uh-oh! We have a little bit of a problem here. Okay? This is odd. And that's going to be a telltale sign of something that we're going to see that this guy has ultimately. And why is that a problem? Well, if we think about it, every time we've written a Lewis dot structure, we always have a bond that's 2 electrons, or we have a lone pair that's 2 electrons. There's no way we're going to be able to pair off all of these electrons when we get an odd number. So let's see how this plays out. In this case, we have H, and we must bind that to an O. We have 7 electrons. We just burned 1 bond's worth of electrons. We're going to have 5 electrons left over. We cannot place them on hydrogen, so we have to place them on this oxygen. Now, if we look at this, we have hydrogen here, 1, 2, oxygen, 1, 2, 3, 4, 5, 6, 7. This guy is not able to get his full octet. Okay. And he's not able to draw any more electrons from that hydrogen there. He has this unpaired electron right here. Ultimately, he is a neutral species, but he is lacking his full valence there. What is to be done about it? Absolutely nothing. This is a type of chemical species known as a radical. A radical is going to have one of these unpaired electrons. They're going to be a very reactive species. In general, this guy's going to go and react oftentimes with other radicals, but other chemical species as well, in order to ultimately obtain his full octet. There's a lot of chemistry behind this, and it's explored a lot in organic chemistry.